Good morning. I'm going to show you how to use this simulation. This is the link. This is where the link will take you when you click on it. And you're just going to press this play button. And you might have to do some troubleshooting with your own computer. However, it should open up like this. If not, just keep trying different things until it does. Intro is fine. Click on intro and it should take you to a blank screen like this. And what we're going to do is build the first circuit on that worksheet. And I will do the first one with you so you can get a handle on how this is supposed to go, and then you can do all the rest on your own. Okay, so I'm going to click and drag and drop different things. I can change the length of these wires. These little blue circles are meant to be electrons or give you an idea of what the electrons might look like. I'm going to take a battery, pop it in there, another wire, stretch that out a bit. It looks like I've got a vertical wire here that I need, a horizontal one, a light bulb. Make sure your wire is connected to both the bottom of the light bulb and the side of the light bulb, or current will not flow through the bulb. Just like in class that one day when we were trying to make the light bulbs light, got to touch both parts so that current flows through the bulb. I'm going to put a switch right here. I'm going to put another switch out here by the battery. Okay. And then I've got a parallel branch above. Scooch this down so I can see it better. There's only one light bulb on that branch and a switch, just so we can open and close switches and see what happens. And there we go. Now I'm going to check to see if it works. I'm going to close all the switches. And here's what we got. Okay, open them back up. Before we go any further, let's just read the directions. So construct each of the circuits below. We just did that, or at least the first one. Each light bulb / resistor is 10 ohms by default. So every one of these is 10 ohms. The battery has a potential difference, which just means voltage, of 9 volts by default. So this is a 9-volt battery. It says complete the RVI, resistance, voltage, current charts, which are just these, mathematically, and check your answers with the non-contact ammeter, which I'll show you in the simulation, and voltmeter. Then answer the questions following each diagram. So the instructions are telling us to mathematically determine our answers before we just find them on the simulation, because it's really easy to just use those tools, find the answers, and just write them in the chart. But the point here is to actually do the math and then check yourself. This is a really good study tool. You can make whatever circuits you want. I encourage you to play around with the simulation and try different things. You can, if you scroll down, you can put random things in like paper clips and dollar bills and a dog. So I encourage you to play around with this. This is a really good way to also check like old problems, or if you're studying for a quiz or test, you can build your circuit in here, check the voltage, check the current, and see if you're right. If you're not, then you know you got to fix something. Okay, let's see. So that's where we're going to start. I'm going to draw this circuit like I normally would, and then I'm going to solve it like we have been. So let's do that. Here's that same circuit, just drawn the way that we've been drawing them. These switches don't make any difference at all. We could really just not even have them here, and our problem solving would not change one bit. So I'm going to just take them out just because they're not affecting anything. And we'll go forward from here. First thing you notice, these two resistors are in series. They are on the same branch. So I'm going to add them, which will give me a resistance of 20 ohms. Redraw my circuit. Here we have. All right, now parallel. Add them, flip it. That's not going to be a nice number, so I'm going to leave that as 20 over 3. Now, we have successfully simplified this circuit. So I'm going to draw the final thing. This is my 9-volt. I'm going to fly. And this is 20 over 3 ohms, which is like 6.67 ohms. And what does that represent? That represents the equivalent resistance. So where does that go? Well, the equivalent resistance is the resistance at the battery. This is what the battery feels. So that 20 over 3 ohms is the resistance down here. Okay, now we can fill out a few more things that we already know. One thing that we already know is the voltage of the battery is 9 volts. Okay, now we can figure this one out. Remember, V equals IR. So for every single row, if you know 2 of them, you can find the third with Ohm's law. So let's do that. Current will be V over R. So 9 over that number. So we end up getting about 1.35 amps for the current out here, for this current. Okay. What's next? Well, what else can we figure out right now? If I stop for a second and I just go back to my main picture, I notice that I have 2 parallel branches. And there's nothing else going on out here with the battery other than the switches, which don't really affect anything. So one thing we know from what we learned last week is that the voltage drop across branches which are parallel is always the same. And because there's nothing else going on out here, the voltage drop for each branch will be 9 volts. Because, look at this. I simplified all of this to be this one resistor. If I look at this circuit, all of the drop needs to happen across this resistor, which means all of the drop needs to happen from this junction to this junction. So the voltage drop for each branch is 9 volts. So we can fill that in. So for 2 and 3 combined, that's what this means. So for the 2 of these together, this entire branch really, the voltage drop is 9 volts. And for this one, which is resistor 1, the voltage drop is 9 volts. Now, on this branch, because there are 2 separate resistors, they will each have their own drop in voltage, but the entire branch combined will be a drop of 9. And you can probably already figure out what each of them will be. If they have the same resistance and the drop for the whole thing is 9, then what would be the drop for each one? Well, it'd be half of that. So this would be 4.5 and 4.5. If these had been different resistance values, then we would have to do a little bit of math, but it's straightforward for this one. Okay, let's see. We also know all of these resistance values. Resistor 1 is 10 ohms. Resistor 2 is 10 ohms. Resistor 3 is 10 ohms. What's 2 and 3 combined? 20 ohms. Oh, and now look. If we know any 2 things in a row, we can find the third. If we know any 2 things in a row, we can find the third. So from here, it's just this over and over again. So, okay, let's do this one. So what's the voltage? It's 9, and this is V over R. So we're doing 9 over 10. So 0.9. And what about this one? We're doing 4.5 over 10. So that should be exactly half of that. So 0.45 amps. This is the same thing, 4.5 over 10. And then this we'd be doing 9 over 20, which reduces to the same thing. So that would also be 0.45 amps. Okay, so there's the math to complete the chart. And now we have some questions that we need to consider. So the first question says,
on a separate sheet of paper, draw a schematic version. We already did that, and simplify it to solve. So we already did that. Now for question 2, it says, explain which part of the circuit is in series. Explain which part of the circuit is in parallel. So what's in series? Resistor 2 and resistor 3 are in series. We've also got some things in series like with the switches, like the switch that was here was in series with this 10 ohm resistor. The switch that was here was in series with these 2 resistors, and the switch that was here was in series with this battery. But really, the only thing that's in series are resistors 1 and resistors 2. So on my paper, I would write for question 2, I basically just write resistors 2 and 3 are in series. And then for parallel, what's in parallel? Well, resistor 1 is in parallel with resistors 2 and 3 together. So I would say in parallel would be resistor 1 and resistors 2 and 3 together. Okay, let's see. Number 3, compare the current in the top branch to the current in the middle branch. Okay, so what's the current up here? That's resistor 1. Current is 0.9. What is the current in the middle branch? 0.45. How do they compare? This is exactly half of this. Does that make sense? Yes, because this has exactly twice the resistance. So if we were to compare them, we would say, with the explanation I just gave, that the current in this second branch is exactly half as much as the current in this top branch because it has exactly twice the resistance. Okay, number 4, rank the light bulbs in order of brightness. In terms of current flow and resistance, explain why. I'm going to show you that one on the PhET simulator so you can kind of see it. And when you run it, you'll be able to see it yourself and answer it on your own. But I'll come back to number 4. Number 5, if bulb R2, which is this one, if bulb R2 were removed, explain what happens to the other 2 bulbs and why. I'm going to show you that one on the simulator too. Try to think about what would happen before you just do it. Try to think, if this were here, how would that change things? How would that affect the current? How would that affect the brightness of the other bulbs? How would that affect the equivalent resistance? You can, if you're not really sure in your head, you can do the math. Take this resistor out, do the simplification, and see what things would do. And then try it in the simulator too. And then last one, determine which bulbs are affected by each of the switches and explain why. So I'm gonna do that one on the simulator too. So let's go over there and do that.
Okay, before I answer questions 4, 5, and 6, I just want to check all of my work to see if all of my currents were correct and my voltages, my resistance values. Well, the resistance values should be right, but let's just check everything else. So I'm going to take this voltmeter, and if you want to measure voltage, it's across the thing. So let's just do one we know already. So if I do this, if I put my probes on either side of this battery, I get a voltage of 9 volts. If I switch them, let's just see what happens. We get -9. So it doesn't change the number, it just makes it negative. So if you get a negative, just switch your probes and you'll be good. So let's see, here's resistor 1. I want to know the voltage drop across this branch. So I'm going to put my probes up here. Oh, I got to turn this whole thing on. It was 0, that made sense. But when I put my probes in and I complete the circuit, we get a voltage drop of 9 volts. If I check this entire branch, I get another voltage drop of 9 volts. If I just check resistor 2, notice it's 4.5. If I just check resistor 1 or resistor 3, it's also 4.5. Okay, now let's check, I'll put this away. Let's check all the currents. All I have to do for the current is drag this thing and just put this over top. So the current down here by the battery is 1.35, and that's the same over here. It's the same over here. It's the same over here because this entire part is in series with the battery. Okay, what about at resistor 1? We calculated 0.9 amps. Let's just check. Yep, 0.9 amps. What about down here? 0.45, that's what we got. Let's just check in different places and make sure it's all the same. Yep, current's the same everywhere in this branch because everything in this branch is in series. So we did all of our math right. Now let's answer questions 4, 5, and 6. So 4 said rank the light bulbs in order of brightness. Well, we can just look. light bulb 1 is clearly the brightest, and then 2 and 3 have equal brightness. And that makes sense. Light bulb 1 is the only light bulb in this branch, which means it's getting all 9 volts. The drop across that light bulb is 9 volts. So it's going to have the greatest energy use and therefore energy output. Down here, these light bulbs are sharing 9 volts. So they are going to be half the brightness of this top bulb, and they're going to be equivalent, same brightness. Okay. Number 5, if bulb R2 were removed, explain what happens to the other 2 bulbs and why. So here's R2. If we were to take this out, what would that make the resistance in this branch? Currently, with both of those in there, the total resistance of this branch is 20 ohms, which is high. If I took this bulb out, what would that do to this branch? Well, it would make the resistance half as much, which means what? Which means this bulb should probably be brighter afterward. But the other question is, will that affect the brightness of bulb 1? So let's go ahead and remove this and think about your answer before you actually do this. I'm going to garbage it. Yep. And then I'm just going to complete that and aha. So bulb 3 clearly got brighter, but did bulb 1 change at all? No. The voltage supplied by the battery is still 9 volts. The voltage drop across this branch is still 9 volts. The resistance in this branch is still 10 ohms. So the current here won't change, and therefore bulb 1 will not be affected by removing bulb 2. However, bulb 3 is clearly affected. And let's just check some other things. Did that affect the overall current? Yes. Notice it's 1.8 before it was 1.35. So the total current went up a bit, which makes sense because we eliminated a resistor. Okay. What about number 6? Determine which bulbs are affected by each of the switches. So I'm going to go ahead and put this bulb back here. And if I open this switch, it only affects that top branch. These 2 continue doing what they're doing. If I open this switch, it only affects these 2. This bulb keeps doing what it's doing. What if I open this switch? Everything stops because this is the switch that controls current flow by the battery. So there we go.